Hey guys, how's it going? So last time we talked about solving proportions involving radicals. This time we're going to be solving equations in general that involve radicals. So remember, the same rules are going to apply whenever you solve. We always look to add or subtract, then multiply or divide, then we look at exponents. So remember, we're going in reverse PEMDAS. So when you evaluate, you go this direction. You start with parentheses, exponents, then multiplication, division, addition, subtraction. However, when we solve, we go this direction. First we add or subtract, then we look to multiply or divide. And in this case, we're going to be dealing with radicals. So the opposite of square rooting something is squaring it. So that is where we are headed. So let's look at a couple examples here. So in this case, we're trying to get h by itself. Well, right now, h is being square rooted and subtracted by 6. Now going back to this, if it's being subtracted, the first thing we need to do is add to get rid of it. So we're going to add 6 to both sides. So I get 10 equals radical h. Now, what's the opposite of square rooting something? Squaring. So I can't multiply or divide anything to get h by itself, so then I deal with exponents. So now I square it. So I get 100 equals h. And that is my answer. That is it. And we can check that. If I plug 100 in for h, square root of 100 is 10. 10 minus 6 is 4. It works. Let's do another one. In this case, x is being square rooted and subtracted by 8. So I'm going to add 8 to both sides. So I get 5 equals square root of x. X being square rooted, so I square it. So you get 25 equals x. I'm done. In this case, a is being added by 6 and square root. That whole thing is being square rooted. So I subtract 6. No, I do not. Why can't I do that? Because of the radical. The radical is over the entire thing. So I can't just subtract 6 away from it. It's being square rooted. This is all in parentheses. This has to be dealt with first. So, actually, so it's being square rooted. The opposite of square rooting is squaring. So I gotta square it. What I do to one side, I gotta do to the other. So I get, when I square root a square, I just get a plus 6 equals 11 squared is 121. So now I subtract 6 because it's being added, subtract 6. I get a equals 115. And we can check that. If I take 115 plus 6, I get 121. Square root of 121 is, in fact, 11. Bang. It works. Let's do another one. It's being subtracted, so I add 5. Ooh, negative 5 plus 5 is 0. Well, when I square 0, 0 squared is just 0. So j equals 0. Square root of 0 is 0. Minus 5 is negative 5. It works. J equals 0. In this case, can I subtract 7? Nope. So I'm going to have to square the whole thing. So I get r minus 7 equals 81. Add 7 to both sides. Oops. And I get r equals 88. 88 minus 7 is 81. Square root of 81 is 9. It works. Same thing here. I can't subtract 4, so I have to square it. So I go b plus 4 equals 81. It's being added, so I subtract 4. So b equals 77. 77 plus 4 is 81. Square root of 81 is 9. And that is how you do those. All right. Let's look at some word problems here. It says solve the equation for the given value. The velocity of sound in air is given by the equation this. So where v is the velocity in meters per second and t is the temperature in degrees. Find the temperature when the velocity of sound in air is 395 meters per second. When the velocity is this, it says find t. So anytime you have a word problem like this and it says find this when given this, it just means plug that number in and solve for the other variable. So like in this case, if it says velocity is 395, guess what I plug in for v? 395 equals 20 square root of 273 plus t. I actually love when they use t's and plus signs, especially with my terrible handwriting. But we'll figure it out. It's all good. So what do I need to do first in this case? Remember, I go back to my order of operations and I ask myself, what's happening to the variable? Well, in this case, the variable is being added by 273, but it's underneath a radical, so I can't just subtract 273. It's being square rooted and it's being multiplied by 20. So before I can attack that square root though, I gotta get rid of this 20. So what's happening there? Is it being added, subtracted, multiplied, or divided? Well, 20 is being multiplied by it. It's the opposite of multiplying, dividing. So I have to get rid of the 20 first. So I get 395 divided by 20 is 19.75. That's gone, and I get this. Okay, now I need to still get rid of that square root first. So opposite of square rooting is squaring. So I square this. When I square that, I get 390.0625. Now, this is positive, so to get rid of the positive 273, I subtract 273. And I get 117.0625 equals t. So round to the nearest degree, roughly 117 degrees. So find the temperature when the velocity of sound in air is 395 meters per second, 117 degrees. It's hot. All right, this one says the formula v equals square root of 64h can be used to find the velocity of v in feet per second of an object that has fallen h feet. Find how far the object has fallen if its velocity is 90. Again, I'm just going to plug 90 in for v. And it said, find how far the object has fallen. Well, if h is the height, I'm just going to solve for h. So, you got to get rid of square root. So I got to square it. 90 squared is 8100. H is being multiplied by 64, so I got to divide by 64. And I get 126.5625. Round to the nearest hundredth, so 56. The height is approximately 126.56, and it said feet. There you go. See, anytime they have word problems like that, just plug in for what it tells you, what it gives you, and then solve for what you don't have. All right, now these, again, we got to look back at our order of operations, and we're dealing with square roots here. So what do we have to, how do we get rid of those first? We don't want to deal with square roots. Opposite of square rooting something is squaring. So in every case here, your first step is going to be to square it. And what you do to one side, remember you have to do to the other. So it's extremely convenient that both sides are just radicals. Now, I'll explain what we do when we get to E and F here in a sec. So for here, all it is 6x plus 8 equals 7x minus 6. Now I combine like terms. Remember, I need to get the x's on one side and get the numbers on the other. So in this case, in order to keep it positive, I'm going to subtract 6x from both sides. And 6 is being subtracted, so I'm going to add 6 to both sides. That's gone. That's gone. 6 plus 8 is 14. And 7x minus 6x, it's just x. I'm done. X equals 14. In this case, same thing. 11x minus 3 equals 10x plus 7. Get the x's all together on one side. So I'm going to subtract 10x. Keep it positive. Which means I'm going to add 3. Gone. Gone. 11 minus 10 is 1x equals 7 plus 3, 10. X equals 10. 4x plus 7 equals 5x minus 6. Subtract 4x from both sides. That's gone. Add 6. 13 equals x. 2x minus 3 equals x plus 4. Subtract x from both sides, make it x, add 3 to both sides, x equals 7. All right, so if we remember from what we've done before when we had variables on each side, that should be something you guys are familiar with. Now, in this case, it gets just a little bit trickier. Again, we want to square it. So in that case, we're going to have to square this whole thing. So here's what that's going to look like. All right, I'm going to warn you, these numbers get a little ugly. So when I square this, essentially what I'm doing here is I'm taking -9 times 7x minus 3, square root of that, times -9 times 7x minus 3, square root of that, equals -1 times 8x plus 6 times -1 times 8x plus 6. That's essentially what I'm doing. So when I multiply these, -9 times -9 gets me 81. And then radical 7x minus 3 times radical 7x minus 3 is just 7x minus 3. But it's important to make sure you keep that in parentheses. Same thing here, -1 times -1 is just 1. So 8x plus 6. So when I distribute this, 81 times 7 is 567. Minus 81 times 3 is 243. Which equals 8x plus 6. Now combine like terms. So I'm going to subtract 8x. And I'm going to add 243 to both sides. So 567 minus 8 is going to be 559x. That's gone. That's gone. And 243 plus 6 is 249. X is being multiplied by 559, so I got to divide by 559. X equals 249 divided by, and that does not simplify down. That is what you get. All right. And yeah, if you were to actually plug that number in for X, you would see that these do both in fact equal each other. All right, let's do the same thing here. Got to square both sides. What you do to one side, as long as you do it to both sides, it's always equal. So this would be 25 times 5x plus 7 equals 36 times 4x minus 7. 25 times 5 is 125. Plus 25 times 7 would be 175. Equals 36 times 4 is 144. X minus 36 times 7 is 252. All right, let's put them together. So I'm going to subtract 125x from both sides. I'm going to add 252 to both sides. That's gone. That's gone. So 252 plus 175 is 427. 144 minus 125 is 19x. X is being multiplied by 19. So I got to divide by 19. 427 divided by 19 is, does that simplify down at all? Nope. So 427 over 19 equals x, which, yeah, is approximately 22.5. Whatever answer works. And that is how you solve for those. All right, so that concludes Unit 9, radical simplification. So dealing with radicals, again, like I said, you're gonna see this again when you get to geometry and advanced algebra. So getting a good idea of how to work with those things now is gonna serve you very well in the next coming classes. Thanks for tuning in, guys. Let me know if you have any questions at all. Thanks.